Good morning to one and all. Today we are going to discuss the topic asymptotic notations. Asymptotic notations is a way to describe behavior of functions in the limit. Abstracts away lower order terms and constant factors. How we indicate running times of algorithms and describe the running time of an algorithm as n grows to infinity. To compare and rank orders of growth, three notations are used: big O notation, omega notation, theta notation. Let T of n and G of n are non-negative functions defined on set of natural numbers. T of n represent algorithm's running time indicated by its basic operation count. Basic operation is nothing. You have to always identify the basic operation of an algorithm which always reside in the innermost loop. Let G of n indicate simple function to compare the count with. Big O notation is defined as big O of G of n is set of all functions with smaller or same order of growth as G of n to within a constant multiple as n tends to infinity. That is, formally we can say T of n is less than or equal to C into G of n for all n greater than or equal to n0, where n0 is a non-negative integer. So this inequality indicates big O notation always represents the upper bound. Examples: 100 n plus 5 is in big O of n square. So neglecting the constant, we can say the order of growth of n is always less than or equal to n square since it is in big O of n square. Same way, half n into n minus 1 is in O of n square. N into n becomes n square, which is in same order of growth as n square. So it is in big O of n square. Big omega notation is defined as omega of G of n is set of all functions with a larger or same order of growth as G of n to within a constant multiple as n tends to infinity. That is, formally T of n is greater than or equal to C into G of n for all input size n greater than or equal to n0. So because we say T of n is greater than or equal to C into G of n, big omega represent the lower bound. Examples: n cube is always is in omega of n square, where n cube is greater than n square. Big theta notation. Big theta notation is defined as theta of G of n set of all functions that have same order of growth as G of n to within constant multiple as n tends to infinity. So here it is theta of G of n. This represents it is the function T of n is bounded above and below by constant multiples C1, C2 of G of n and C1 G of n. So the time bound is between the two curves C2 G of n, C1 G of n for all n greater than or equal to n0. That is, it is bounded below and above. The example: half n into n minus 1 is equal to theta of n square. How to prove the two equalities, right inequality and left inequality, and prove half n into n minus 1 is in theta of n square. Same way, these are the few examples. 2n square is in big O of n cube, and the proof is where c is equal to 1 and 0 is equal to 2. 100n square plus 100n is in big O of n square. So here n square is considered for comparing with the n square on the right side. Proof is given. So 100n plus 5 does not belong to omega of n square. According to the definition of omega, it is a set of all functions with same order of growth or larger of order of growth than g of n. So it is not because n is less than n square. According to the definition, t of n should be greater than or equal to c into g of n. Hence, we can say 100n plus 5 does not belong to omega of n square.